In this video we're going to talk about dot plots. Now a dot plot is a type of graphic display used to compare frequency counts within categories or groups. As we'll see, it's a very straightforward technique. It simply means we take a category and we represent the number in the category by a series of dots. It's as straightforward as that. So it's a graphic display used to compare frequency counts within categories or groups. Now, the overview. Well, a dot plot is made up of dots plotted on a graph. Nothing very strange about that. It's the name is a giveaway. It's a dot plot. So it's the number of dots plotted on a graph. Each dot represents a specific number of observations from a set of data. Unless otherwise indicated, it's reasonable to assume that each dot represents one observation. Of course, that may change from graph to graph. It may be, if there's a large data set, that each dot would represent many. It could represent hundreds or even thousands. So it depends on what we're talking about. But generally speaking, each dot represents one unit. Now the dots are stacked in a column over a category, so that the height of each column represents the relative or absolute frequency of observations in the category. So we simply take a category, whatever that is. It could be the name of a place. It could be, let's say, Manchester, and the number of dots over it could represent the number of houses sold in Manchester last week. Now that would be a valid dot plot, and we could compare Manchester then with other cities. Of course, the more sophisticated we want to be, the more we want to make the data conformable. We want to be able to compare one city with another, perhaps, so we'd have to adjust for the size of the population and the working population and disposable incomes, and so we'd have to refine the data greatly. But in the example we're talking about here with dot plots, it's a very straightforward exercise. The pattern of data in a dot plot can be described in terms of symmetry and skewness only if the categories are quantitative. If the categories are qualitative, a dot plot cannot be described in those terms. So we can't do any analysis if it is qualitative. If we're comparing two geographic areas, we're comparing London to Manchester, we can't take an average. It's nonsense. We can't add London to Manchester and divide by 2. It doesn't make any sense. So we have to have quantitative data before we can do analysis. So dot plots can be used just simply to represent a picture of what's happening in terms of, let's say, total house sales in an area in a given time period compared to a different area. But we can't do much analysis over and above that. Compared to other types of graphic display, dot plots are used most often to plot frequency counts within a small number of categories, usually small sets of data. And dot plots are most effective when we're dealing with small amounts of data. Large amount of data, dot plots are not a good way to go. It doesn't look good, and it's difficult to do as well. Consider 6 schools here, A, B, C, D, E and F. And let's say the top class in the school is given a test in mathematics. Now the results of the tests are represented using dots. So each dot represents, let's say, 10% pass rate in the test. So school A has got 4 dots, so it's got 40%. School B has got 50%, it's got 5 dots. School D only has 2 dots. School E had a 30% pass rate. School E had 3 dots. So we can represent the pass rate in each school with the number of dots. And we can see the picture straight away then, which school is doing really well, which school is not doing so well in this particular test. As I said earlier, we can't do much analysis because we can't take an average of schools C and D and add 70 or 7 dots in C to 2 dots in D and take an average. It doesn't mean anything. So it's not suitable for analysis, but it does show a picture. And that's what dot plots are meant to do. It does show graphically what's going on. Here's our school. Now each dot represents a pass rate of 10. Therefore, school A had a 40% pass rate, 4 dots at 10% each. And that's all, as I said in the last couple of slides, that's all it's doing. School B had a 50% pass rate. It has 5 dots at 10%. And we do that for each one. The distribution of the dots does not indicate skewness. School A and School B, etc., are categorical variables. In other words, they're just the names of the schools. They're categorical variables. They're just the names. They're not variables that we can analyze quantitatively. We can't take averages and work out standard deviations, and we can't analyze them quantitatively. They're just the names of the schools. School A, School B, School C. So we can't look at this and talk about the skewness of the figures. What we can do is just simply look at the number of dots, and it represents the performance of the schools pictorially. The number of patients attending a hospital over a 7-day period is represented in the dot plot below. Each dot here, say, represents 25 patients. Now, you can see Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Wednesday, most people are admitted to hospital. On Sunday, very few are admitted to hospital. So now a picture is starting to emerge. The figures seem to be skewed towards the early part of the week, Monday, Tuesday, Wednesday. Thursday is also quite high. I think it's the same as Tuesday, but after that it tails off. And we expect to find the average number of admissions towards the Wednesday figure. So there is a skewness in those figures. And the reason for that, of course, is that we've got time on the horizontal axis. And we can talk about time being a continuous variable. We can talk about Tuesday to Wednesday. Well, was it Tuesday 12:30 or Tuesday at 4 o'clock in the afternoon, or when was it? So we can imagine it being a flow over that period. We could, of course, just join the tops of the figures together, and we'll get a picture of when most people were admitted, which again, of course, is just Wednesday. But we are drawing a graph now showing admissions, and it's skewed to the right. And the reason for this, the reason we can do this, we can make this statement, is because the data on the horizontal axis is time. Previously, it was a categorical data. It just was the name of a school, and we can't take an average of 2 names. It doesn't make sense. But here we could talk about time, and we can talk about when the patients were admitted across the whole period of time. So dot plots, they can be used quite simply to represent pictorially certain events using categorical data, using data, the names of schools, the names of areas, or products, or whatever it is we're looking at. Or if it's the data on the horizontal axis is amenable to statistical analysis, we can work out skewness and distribution and so on, again using the dot plots as a basis. So that's what we mean by dot plots, and that's the use of dot plots, and that's all we're going to deal with here. So let's leave it at that and say thank you for watching.